So we continue our tutorial here. This is tutorial number 19 from the previous problem. If the temperature, sphere size, and velocity remain the same of air flow, at what air pressure will the Reynolds number to be equal to 10,000? So this is just the idea of how to measure a viscosity later on. So the idea is we have a sphere like this one. So we have the diameter is 0.01 meter. The velocity is 18 meter per second. So the temperature is 20 degrees Celsius and the mu of air is 1.81 times 10 of the minus 5 Pascal second. So if we calculate the Reynolds number, so we have this one. So we found that the question is at what air pressure will the Reynolds number equal to be 10,000? So from the Reynolds number here, so you know that from this question, the question is about the air pressure, but you must know that when we are dealing with gas, so the air pressure and the density is actually quite fragile. So means that here from the Reynolds number here, so we don't know, we could calculate the value of the density. So we found that the density is 0.7183 kilogram per meter cube. So and then from the density, okay, from the ideal gas law here, I think you still remember density P. I remember as P is equal to rho RT, or the rho is equal to P over RT. So and then we could change the pressure is P rho RT here. We substitute all the values, so we get it is around 60.4 kilopascal. So however, in our syllabus, actually we are not focusing about the different pressure like this one. We are focused on the viscosity for the first chapter here.